All right, so this unit is all going to be over circles. So we first have to kind of review some vocabulary and have new vocabulary. So first is a circle. So that is a set of points that is equidistant from a given point. All right, that given point is called the center. So this is the middle of the circle. Middle, and it's the name of the circle. So you name the circle by the letter in the center. And so if we have a circle here drawn and we have, okay, let's just say it is center R. Well, when we draw the symbol for circle, we do pretty much the same thing, and the symbol is a circle with a dot in the middle, and then we put the letter R next to it. So this is read as circle R. So just so you know that the symbol for circle kind of looks like a circle, looks like a little donut, and then it'll have a letter by it, so that would be circle R. Now the radius is a segment whose endpoints are the center and the circle. So a radius is going to have one endpoint on the center, and the other one is going to be any other point on the circle. Next, we're going to have a chord. A chord that is a segment whose endpoints are both on the circle. And we'll see pictures of these in just a little bit. Segment with endpoints on the circle. The diameter is going to be a special chord, so it is a chord that contains the center. A secant, so this is where it gets a little bit different. A secant is a line. So the other ones you notice were segments. This one is a line that intersects the circle at 2 points. The circle at 2 points. And the tangent is a line, or sometimes it can be a line or a ray that intersects the circle at 1 point. All right, great. So let's see what these look like now. So we're going to identify the special segments, and we're going to tell whether the line, ray, or segment is best described as a radius, chord, diameter, secant, or a tangent. So if we look at BC, and here is BC. So BC is a segment, because you notice here the symbol on top is a segment. So it's going to be very important for you to pay attention to the symbols that are on top of the letters, because remember, secants are lines, and tangents can be lines or rays. These other three here, these are all segments. So again, the symbols are going to be important. So make sure you pay attention to those. So BC, it is a segment that has an endpoint of the center and any other point on the circle. So BC is going to be a radius, because C is the center and B is a point on the circle. So next is line EA. So if we're going line EA, we're going all the way through. There is line EA. Well, a secant is one of the ones that can be a line. So when it says a line, and you notice the symbol here, this is a line, it can be a secant or a tangent. So since it intersects the circle at 2 spots, that is a secant. And ray DE, so we have D to E, so here is this ray DE. So it's starting at D, going through E, and it's only touching the circle at 1 point. So if it's talking about a ray, it's going to be a tangent. All right, so remember, these 3 here, these are segments. They can also, a diameter, they're segments. You're not going to see it any other way. Secants, this is a line. Tangents can be a line or a ray. So let's look at example 2. They just want to give the lengths. So if we look at radius from circle A, here's circle A. It is the smaller circle here, and they want to know how long is the radius. Well, the radius goes from the center to the side, so that's just 2 units. Well, the diameter is double the radius. So when you have the radius, you just double it to get the diameter, so that would be 4. And if we look at circle B, which is the larger circle, here's the center, B. You see how they name it here, circle B. Well, the radius from the center to the side, 1, 2, 3, 4. So there's our radius. The diameter is always double the radius, so it is 8. Now, common tangents, the circles. All right, so common tangents are, again, tangents are lines or rays that touch the circle in one spot. So you're going to see how many you can draw. So see here, if the circles are touching like this, and they are circles that are not inside of one another, you can draw a line straight through here, and it's going to only touch the circles at 1 point. You can also draw lines on the outside of each circle, and that's only touching the circle at 1 point. And you can also draw a line on this side, which is only touching the circle at 1 point. So in this case, we have 3 common tangents of those 2 circles. Now, if the circles are overlapping, you can't really draw one in the center, but you can still draw 2 along the sides, and they're going to be touching the circles at those 1 points, so that's 2 common tangents. If the circles are inside of one another and they are touching at 1 point, then you can draw a tangent that has it touching at 1 point. So there you can see the different ways that you can draw tangents and how many. Then the next part about tangents is that if we have a line that is tangent to a circle, if and only if the line is perpendicular to a radius of the circle. So what that's saying is that this line right here is only going to be called a tangent if it is indeed perpendicular to the radius. And you can also say, okay, well, this is only the radius if indeed it is perpendicular to the tangent. So here we have perpendicular, and a thing that helps us with perpendicular is going to be our right triangle, because we can create now with the tangent and the radius, we can create a right triangle. And remember, in right triangles and Pythagorean theorem. So if we use Pythagorean theorem, we can test to see if it is indeed a right triangle. Remember, if it is a right triangle, that this formula, it will indeed equal each other. The legs, the sum of the legs squared will equal the hypotenuse squared. So in example 4, they're telling us that RS is the radius, and they want to know, is ST tangent? So if ST is tangent, it is going to indeed be perpendicular right there. Well, the only way we know it's perpendicular is if we do Pythagorean theorem, and indeed the sum of the square of the legs is equal to. Now, what you have to be careful about on these pictures is you see this 26 here is just for this outer portion of RT. It's not for the whole entire thing. What you have to apply from what we just learned is that this radius here, you can take a radius and drop a segment from any point from the center on this circle. So you see here we have another chunk of a radius. So it's our responsibility to say, okay, well, this little piece is 10 as well. Because anywhere you draw a segment from the center to the side is going to be a radius, and you can then say that those are congruent lengths. So now we have one leg is 10. We have here this other leg is 24. And then now we have this whole entire hypotenuse is now 36. So if we continue to check the Pythagorean theorem, we get, all right, that 10 squared is 100, 24 squared is 576, 36 squared is this. Then we add these two together and get 676. So we see there is a big discrepancy here that indeed that these do not equal each other, so therefore ST is not tangent to the circle. Now you can look and we can do it again. All right, is RS a radius of circle R? So here is RS. They want to know if it's a radius. Well, it's only going to be a radius if it is indeed perpendicular to ST. Well, here we're missing again a little piece of the hypotenuse. You can see we only have this little piece. We've got to say, okay, if this radius is 5, that means this radius is 5. So this gives us 13. So we have a 5, 12, 13. And if you remember correctly, that's one of your Pythagorean triples. 5, 12, 13 are always 3 side lengths that are going to form a right triangle. If you don't remember it, you're still doing Pythagorean theorem here, and you're squaring everything. And then you're going to add it together, and you're going to see that yes, indeed, this is a yes. So again, you have that memorized, 5, 12, 13. If you have 5, 12, 13 memorized, then you really don't necessarily need to do all of that work. All right, I would like you to do this number 2 on your own. Tell me, is ST tangent to circle R? And once you've worked it out, you're also going to answer and give me your answer in the multiple choice question. All right, so we can also use Pythagorean theorem to help us find the length of a radius. So they're already telling us, okay, that in the diagram, that point B is a point of tangency. So where that tangent intersects the circle is called the point of tangency. So if they're telling us a point of tangency, then indeed it is a tangent, which means that is indeed a 90-degree angle. So since we already know it is a 90-degree angle, we can use that information to help us solve for R. So let me show you how this sets up. So basically we're still doing Pythagorean theorem, and we have one leg here. That's R squared. Right? That's a squared plus b squared is 77. That's going to equal the hypotenuse squared. Well, look at what your hypotenuse is. You don't have one number for the hypotenuse. Your hypotenuse right now as it sits is the expression r plus 49. So you have to square that whole entire expression r plus 49 squared. So this is where we have to remember a little bit from algebra about FOILing and how to square a binomial. So remember, when you square a binomial, it does not mean that you take that 2 and you distribute it to each part. That's not what that means. Squaring something is taking anything that you have and multiplying it by itself. Well, what we have right now is this binomial. So we have r plus 49. We have to times it by another r plus 49. Which means now we have to FOIL, first, outer, inner, last. So you're going to do r times r, which is r squared, and then r times 49, which is 49r. Again, 49r. And then you have 49 times 49, which gives you 2401. So this right here turns into all of this. So we're just going to simplify it. All right, so here we have r squared plus, we have 77 times 77, which is 5929, equals r squared. I'm going to combine my like terms. So 49 plus 49 gives you 98. 98r plus 2401. Now I know these are big numbers. I don't want you to get scared. Now look what we have. We have an equation with r squared on this side and r squared on the other side. So all those are going to do is cancel each other out. So right away you get rid of your r squareds. Now you have 5929 equals 98r plus 2401. So this is just your general two-step equation now that you're just solving for r. So you're subtracting 2401 from each side. So 5929 minus 2401 is 3528 is equal to 98r, and then we're going to divide by 98. So our radius here is 36. All right, that is how to use tangents in Pythagorean theorem. Next is theorem 10.2, where it says tangent segments from a common external point are, and they are going to be congruent. So basically, again, we have two tangents. All right, a tangent is a segment, a line, a ray that touches the circle at one point. It's touching at, one is touching at R and one's touching at T. We have two separate ones, however, they have a point in common S. So if you have two tangents touching the circle and they're both extending from a common point, then those tangent lengths are equal. So you can see in example 6, it says that RS is tangent to circle C, and RT is also tangent to circle C. They want us to find the value of x. Well, since these tangents are both coming from R, we can say that they're equal to each other, and you know anything that is congruent is also equal, because congruent pieces have equal measures. So we have to take the square root of both sides. To get rid of an x squared, you always take the square root. Take the square root of both sides. X is 7.